with homework 13, and we're going to do this sign. All right, a new sign is hung outside the U-Hart commissary, and it weighs 200 pounds. It's got a pin joint here at A that doesn't support any moments, only forces. And the dimensions are these two are 3 feet long, and this one is 2.5 feet high right here. AD right here is 1 foot. As the AC, this is 1.5 feet, and this is 2.5 feet. And we want to find the reaction forces at A, and we want to find the tension in each cable, and we need to make an FBD for all this stuff. So maybe I will pause this so that we don't have to see me drawing a video and make the video shorter. But I lost my ruler. I don't know what I did with it. That's weird. It's like I haven't moved. I didn't get up from the table. Nothing happened. It's not in my lap. Didn't fall down. It's disconcerting is what that is. Okay, there you go. Magically shows up. All right, so we're going to try, let's see, we know that we have this force coming down. I guess we'll try to draw sort of an FBD. Sort of an FBD. It is an FBD. All right, so the way that I had drawn this right here, that cable kind of gets in the way, so I might exaggerate some of that. I can't believe I can't find my little ruler. It's messed up, man. I have a lot of them, actually. I usually give them away to students. It's my like, hey, here's a gift from me to you. This is the weight, so that's 200 pounds, acting at G. I'm just going to draw, it up like over to this direction right in there. F, A, C, no, B, C. And then I got another one coming up over this way. F, B, D. And then we have a force right here. Now, I'm gonna write them out in their components. So this is gonna be RAX, RAY, and then I think I'll draw it in the positive direction here. So R-A-Z, RAZ. Okay, and this is an FBD. And I guess if I was going to be 100% clear, I would give it some X, Y, and Z. It's good to put this little coordinate axis that goes along with this. Now, some preliminary stuff that I could take care of is I really should turn these into their vectors, right? So you remember doing this. Hopefully you're still good at it, all right? So let me go. This is supposed to be B. That's supposed to be BC right there. It looks like a D. BC. And so we're going to go C with respect to B. It's going to be this first one. Come on, focus. Focus. Okay. So it's in the negative X direction by way of 6 feet. And it's going to go upwards by YAC 2.5 feet. And then it's going to go in the positive ZAC 1.5 feet. I meant to put a K. Very tired. And let me get the magnitude of this. All right, so if we were going to have our F BC as a vector, it would be FBC times -6 over 6.671 I plus 2.5 over our 6.671 J plus our 1.5 over 6.671 K, or that's going to be -0.9. Do I want to put a, yeah, I don't know, what's the best way to do it? To write it all over again? To write it with each one? Sure. Right, -0.8994 FBI 2.5 yeah, 0.3748 FBJ. I have to skip to the next line. 1.5. Well, I guess I'll type it in. 671. No, too many sixes. 7, 1, divide 0.2249 FBK. Okay. That seemed to take a lot longer. I should have. Let's do this next one here then. BD. D with respect to B. Okay, so that's going to be equal to, once again, a -6I plus, now we're going to go up the AD, which is 1 foot. Plus the Z is going to be a negative, right? And negative ZAD, which is 2.5 feet. Get the magnitude. I can put them on the same line. Save a little bit of space. 36 plus 1 and 2.5 squared plus a square root, and we get a 6.576. Not that much difference in length here, huh? So let's start right over here onto the left. BD. It's going to be FBD times -6 over 6.576 I and 1 over 6.576 J plus -2.5 over 6.576 K. We weren't able to fit everything over onto this one, so why would we do on this one? So let's just write it again down the next line. Try -0.9123 FBD I. Can you imagine that there's actually professors that ask this question on exams? You know how long this would take? I don't know. I don't know how they could get away with it. Can you imagine having to do this on an exam? You probably already think it's terrible the way it is. I got you. All right. But I'm telling you, I'm watching other professors and they're asking these questions. on an exam, and it just would take too long, I think. I don't think a student could possibly finish it. I try to ask a shorter question if I can. All right, let's see. All right, so other things to find out from this. Well, we're gonna have we're gonna have to do the sum of the moments. Probably the best to do the sum of the moments about A. That's the way. That's the place to go. Sum of the moments about A. That's gonna get us these cables right here. I believe. I think it's gonna give us these cables. They're gonna balance out. So, and then once we do that, we get the sum of the forces. We get A. So we're going to need to get the position vector of B with respect to A, and that's easy. That's just 6I feet. And then we need the position vector of this guy right here. And we didn't actually get told what his dimension is going to be in the vertical direction right here. I guess we kind of needed to know that. I'll show you that it didn't matter, right? We're going to make up a number. We're going to call this Y BG. And we're going to set it equal to, well, what does it look like? 1.5 feet. Why? Because that looks like a square right there, right? This looks like it's like, you know, kind of like this is about that size. Something like that, close. It's how I do when I pick out the numbers, just to kind of look at it. So our G with respect to A is going to be equal to, I just said 6. No, it's 3. Okay, good. 3. Negative 1.5 J. It's not going to matter, is what I'm saying. All right, because there's no forces that in that direction. They could be perpendicular to that. That's going to cause anything. All right. So let's take the sum of the moments about A. So we got 3 forces. And one of the forces, by the way, we forgot to write it down anywhere. Where are we going to put it? Let's put it over here. WG is equal to negative 200 J pounds. There you go. So we got 3 forces. So you have to have 3 of these things. I know these are long problems, right? So you got R B with respect to A crossed with F. Let's go BC first. Plus R B with respect to A crossed with F BD plus WG. Oh, come on. RG with respect to A crossed with WG. Let's see if we can get it all on this bottom line. We'll just switch to a new piece of paper. So I, J, and K. And all this is going to be is 6, 0, 0. Though it's going to take a lot of room. Darn. All right, so this is BC first. There's a lot of opportunities to mess this thing up. So over here, negative 0.8994 FB. 0.3748 FB. 0.2249. Looks like a 49. 49 FB. Let's give ourselves a lot more room here. 6. 0 or 0. We're going to be very thankful to get rid of things with those zeros, I think. This guy we just wrote out down here. Well, it's a lot. Negative 0.9123. FBD. Oh man, I messed up over here, right? He should be BC. BD. .1521 FBD. And negative 0.3801 FBD. Plus, okay, IJK equals 0. Let's hope we could fit it in here. Remember I said it was going to be 3, negative 1.5, and 0, and then a 0, and negative 200, and 0. Right? Wow. This is exciting theater. I know. You are just thrilled. You are just riveted. You can't take it. And why am I still recording these videos if no one is watching? I'm going to take a poll. Secret poll. Secret poll, do you watch the video? What happened here? Started to fade out on me. Is that because it's been going for so long? 16 minutes? Maybe it's just that, you know, I'm tired. It's tired. We're all tired. Things are tired. It's 11:50 on a Sunday night. And I'm regretting making the homework this long. You deserve what you get, Dr. Deal. Yes, right. You don't have any sympathy as I am trying to make you into engineers. Okay, so let's start with I. Nothing versus nothing, right? J. We got that and that, right? So we do have something to J. Got to make sure that we remember he's negative, right? Because we always subtract out the J when we do that part of it right there. So that's going to be the 6 times the 0.2249 times our FBC, right? And then it goes across from there. So it's that right there is all J long. And then let's try K. All right, that cross with that minus that cross with that, right? So now for the K, we're going to have plus, and we're going to have 6 and 0.3748 FBC and nothing else, right? Because that's going to go that against that minus that. Okay, K. Great. Now for this one, same dealio. Let's go for the I. That and that, these all cross out. Go for the J, that to that, and that and that. All right, so this is the only one, but remember, he's negative. And he's going up with a negative 0.3801 FBD J. And then we go for the K. And so it's going to be that and that and that and that, right? So but it's going to be that 6, which does not look like a 6 anymore. That's 6 with this guy right here, or a 6 with a 0.121 FBD. Got to be careful there. FBD, FBC, FB. Okay, got it right. And that too is a K. And then lastly, we're going to go this one with, we go for I's, right? In here. So I, that and that and that and that. Okay, we're golden. J's, this and this, this and this. We're golden. K, that to that, and look, that one and that one. So that one got to 0 right here. So all we have for K is a 3 times negative 200 right there, and that's going to be k equals 0. So let's take a look at what we have. In the I, nothing in the I. No, the I's have it, nothing. So in the J's, we have a negative. Let's turn that into a number. 6 times 0.2249 is going to be 1.3. Okay. Doesn't seem like it's enough. Yeah, negative 1.349 FBC. J here. Negative. Okay. So we're going to have 6 times 0.3801 right here. So plus 2.281 FBD. And that's it. So there you go. There's one equation for us. Then we got the K right here. And in the K, we have 6 times this right here. So 6 times 0.3748. So I get, and that's positive, yep, 2.249 FBC. All right, and then here goes another one, okay. And yeah, I think that's going to be positive. 6 times 0.121. Is that all I had? 0.121? 0.1521. Right there. 0.1521. I'm going to make a mistake. I'm so tired. And it looks like that's positive, yeah. 0.9126 FBD. And then that's going to be minus 600. I'll do that in my head. All right, so that's equation 2. So we have 2 equations and 2 unknowns. Don't you love it? Okay, so I'm just going to solve for FBC. Is going to be 2.281 divided by 1.349 times FBD. 2.281, 349, and I get 1.691 FBD. And I place him back into here. So I get 2.249 times 1.691 FBD plus 0.9126 FBD equals 600. So I get FBD. So 2.249 times it, add it with this, and then divide 600 by it. And we get 127.2 pounds. Huh. Okay. And then we put it back up into this other guy. We get FBC is equal to 1.691 times 127.2, 1.691. So we get that it's 215.2 pounds. And now we take the sum of the forces equal to 0, right, as vectors. Unfortunately, we have a lot of math to do because, well, we just got to do it. All right. So let's do everything in the. Let's collect everything in the I's. So we're going to say that R A X. Let's see. Let's write out the thing though. We're going R A plus F B D B C plus F B D plus W G equals 0, right? So let's go through the I's for all this, and then all the J's, and then all the K's. It's mostly going to be J's, I would think. There'll be a lot. I think there would be a lot of J's, but I guess it's going to be something for everybody. Okay, so for where did we go here? We now need to stick in these values back into these things up here. So this equation right in there. It's almost better to write this out, isn't it? No, I don't feel like it. All right, so it's going to be plus a negative 0.8994 times 215.2, and then we're going to get a negative 0.9123 times our 127.2, and then there's nothing here, right? That's I. Let's solve that right now, right? Next, we have R A Y, and then in the where'd you go? Come on, don't fall asleep on me. Oh, that's because I have it plugged in. Sorry, baby. I'll plug you back in. That's why you want to go to sleep, isn't it? There you wake you back up. Wakey, wakey. Or how small this is. Okay. Where did we go? Where did we go? Where did we go? We go over here. 0.3748 times 215.2 plus 0.1521 times 127.2 minus 200. J. So we can find our, and then plus RAZ, and that's going to be plus 2249 times, where'd you go? This guy, 215. Plus, we're getting towards the finish line, negative 0.3801 and 127.2, and there's nothing else, and we say it equals 0. So we could find $215.2.8994 times 0.9123.127.2 times, add them together, and it's negative, so we get the rate to, okay, so 309.6 I, lovely, plus right here, okay, so We got a lot. We got a lot of this, but here's this negative too. So let's see if it. Let's see which way it goes. It's going to go up or is it going to go down? 0.3748. Boom. Okay, that's only 80.6. So I think we're going to be good there. 0.1521. 127.2. Boom. That's only 19.35. Add them together. That's only. Oh, that's almost exactly 100. That is 100. You crazy bastards. That's interesting. I didn't expect it to be just half of the weight. Half of the weight got handled by the cables, and half of the weight got handled by. I guess that kind of makes sense. Yeah. Okay. And then this one actually might turn out to be 0. There's a good chance this is 0. So let's try it out here. 0.2249 and 215.2, right? We end up with 48.4. So let's see what happens here. 0.3801 and 127.2. Oh, they just come out. This is it's pretty much just, that was just a an error in here. It's a round off error. Right. So did I just drop? That's funny. I just dropped my triangle. I set it on my leg. So I must have done the same thing with my little red ruler, and he went flying. Oh well. You didn't see where he went. Little Boba Fett. Here's my huge Boba Fett. My wife buys me these things. She's nice. So if you're putting the home version to drink a game, this is the time when you take a swig. That's right. There he is. I knew I would find him eventually. I did not know that. Found him. All right. We caught that all on film. That was worth it. Okay, let's finish the problem. As it's late at night, it's 12:06. I have to go to bed, but I wanted to get this done before I went to bed. I'm complaining about your homework. Okay, let's see. Make sure we box our answer. So I'm obsessed with people not boxing their answers. And we will say that the force of BD is 127.2 pounds tension, and the force of BC is 215.2 pounds. And you say, well, shouldn't that be a vector? I'm like, if it's just the tension, if someone's going to ask you for the tension in something, you don't have to turn it into a vector necessarily, I don't think. It only goes one direction, same direction as the rope. So there you go. How long did that one take? Whee! That was long. That means we got another half hour before I go to bed. All right. Keep at it.